Hi guys, welcome to my YouTube channel, and in this video I will briefly discuss about electric potential at point P. It means that we need to calculate the electric potential at point P by removing or by moving the point from one position to another position. So in this case I will draw a unit positive charge or test charge or a source charge in which electric field lines propagate in all directions. So in order to further understand its behavior, we will place a point in order to calculate the electric field potential or electric potential at point A or point B. It means that the particle or a charge or test charge will replace or placed a point from move from point B to point A. So we need to calculate. In this case you see that point B is outside the electric field strength or electric field intensity, and point A is inside. So we need to calculate the potential at point A, because the particle or a charge is moving from outside to the inside of the electric field intensity. So the distance between center or origin from point A is RA, and distance from center to point B is known as RB, and the difference between RB and RA is known as delta R. So the total distance RB or is equal to RA plus delta R, and we can calculate it will be RB minus RA. It is in mistake. So we know that the potential difference is equal to minus E into delta R, which is equal to product of electric field intensity and displacement, or delta, or change in displacement or change in distance between them. Furthermore, I will briefly discuss its units, because delta R can also be calculated from these expressions, and delta V can also be further simplified, because we know the value of E is equal to 1 over 4 pi epsilon naught q over r square. So in here it will be q over r square. I will replace it in the form of r square, which is q over r I have written, and it will be in the form of q over r square. So r is equal to RA plus RB over 2, because it is a midpoint between RA and RB. So in order to further understand this, we need to find out the value of r square. So here is r square. We have r. So first of all we will take square on both sides in order to calculate the value of r square. So r square is equal to RA plus RB over 2 RA plus RB over 2 whole square. It will be whole square, and if we open the value of RA plus RB whole square, then it will be in the form of RA square plus RB square plus 2 RA RB over 4, because the square of 2 is 4. So it will be in the form of RA square plus RB square plus 2 RA RB over 4. So in order to further understand this, these 2 points are very close to each other. Point A and point B are very close to each other, and we can say that RA and RB are almost same or equal to or nearly equal to R. So it will be RA is nearly equal to RB or nearly equal to R, and we will replace these values. So these values will be in the form of RA and RB, because we are dealing with 2 points, and these 2 points having point A and point B. So we will write in the form of in this expression. So r square will be RA RB, it will be 4 into RA RB over 4, because these upper terms are 4 terms, and these are in the form of square, and we can write it RA RB. So the r square value is RA RB, and we can replace this value in this expression. So we know that E is equal to 1 over 4 pi epsilon naught q over r square, and we know the value of r square, which is RA into RB, and we will replace this value in this expression. So E is equal to 1 over 4 pi epsilon naught q over RA into RB. So we know that change in potential or potential difference is equal to minus E into delta R. So minus E into delta R can in the form of delta V is equal to the change in potential from point A to point B is equal to minus E into delta R, which is equal to RA minus RB. So if we change the value or multiply the minus sign in the bracket term, so it will be VA minus VB is equal to E into RB minus RA, because due to minus the terms will be replaced in each other, and the negative sign will also be replaced, and we will change the order also. Furthermore, this value can also be find out the value of E can also be put in this expression, which will be VA minus VB, or delta V is equal to minus E into delta R. So it will be E into RB minus RA. This is the expression I am writing again. So delta V is equal to VA minus VB is equal to E. The value of E will be 1 over 4 pi epsilon naught Q over RA and RB, because we have calculated, and RB minus RA will be same, and we will write it RB minus RA. In order to further simplify this mathematically, we will write in the expression of Q over 4 pi epsilon naught into RB minus RA over RA and RB. And furthermore, in order to simplify this, RA and RB in the denominator, so we can say that it will be divided equally by every term. So Q over 4 pi epsilon naught RB over RA RB, it will be cancelled, and RA will be remaining, minus 1 over RB will be remaining in the other side. So in order to further understand that this is the final expression of the potential difference with respect to the 2 points. In order to further understand this, VA minus VB is equal to Q over 4 pi epsilon naught RA minus RB. So for example, when we are taking the point from the infinity, then potential at point infinity or potential at point B is equal to 0, because there will be no potential difference or potential at that point, because it is out of range. So at infinity potential will be 0. We will put the value of potential VA minus 0 Q over 4 pi epsilon naught, and the point is at infinity, 1 over infinity is equal to 0, and we will also put this value VA minus 0 Q over 4 pi epsilon naught 1 over RA minus 0. This is the final expression, and if we simplify this expression, the final term will be potential at point A is equal to Q over 4 pi epsilon naught into 1 over RA. Or if we simplify or modify this, VA is equal to, or V is equal to Q over 4 pi or 1 over 4 pi epsilon naught Q over R. This is a final expression of potential at point P or at any point within the range of electric field intensity. The formula of potential is equal to 1 over 4 pi epsilon naught Q over R. This is the final expression, and up till now we have discussed about the point charge or source charge, which is placed in the center, and it directs all the electric field lines around its all the axes. So the electric field lines are drawn here. We have put the point A and point B here. Point A is inside the electric field and point B is outside, and if we replace the point B from point A, or if we move from point B to point A, we have calculated the potential of point A or potential at point A within the electric field range. Up till now we have finished this. If you have any question, you can contact me or you can comment at this video. See you soon. Bye bye.